Okay, it looks like we've hit the top of the hour. Chuck, do you want to kick us off?
Absolutely. Thanks, Ross. Can you hear me okay?
Yeah, we can hear you just fine.
Awesome. So we want to thank you all for attending. My name is Chuck London. I am the academic account rep for Western Kentucky at JUMP. Just to level set, Western Kentucky has what we call a campus-wide license to the JUMP academic suite. That allows any faculty member or student at the school to download JUMP Pro directly to a personal computer. We know a lot of folks do homework or academic research work outside of the school, so we do allow for you to download the software directly to a home computer. You can It can be downloaded and installed on lab computers or classroom computers as well. So if you want to use Jump Pro in the classroom, all the students can access it in the classroom as well. I believe Dr. Juadar has the instructions for how folks there can access the license, so feel free to reach out to her if you have any questions about that. As the academic account rep, I am happy to answer any questions anybody would have about the license, whether they're eligible to use it, what version you guys have. As an annual license holder, you're always eligible for the latest release, which right now is Jump Pro 16.2. And I'm happy to answer any of those questions. I believe Ross will share my contact information, and it was also included in the invite. So please do keep my name and contact information handy. If you enjoy the webinar today and would like to set up a different topic in the future, whether it's more advanced or just a deeper dive into the basics, I'd be happy to schedule that for you. We also, in the past, we've done guest lectures for classrooms. If that's something that would interest you, feel free to reach out to me directly as well. I did want to introduce Ross Matusalem. He's an academic ambassador at JUMP. What that means, he actually comes from teaching. He's taught before, and he's used JUMP and other statistical tools. And he's going to show you some of the basic features of JUMP Pro today, but you'll be able to answer most of your questions about using Jump Pro. So please do feel free to ask. Thanks, Ross.
All right, thank you, Chuck. And thanks everybody for taking a little time. I know you're on your spring break right now, so appreciate you checking in at 9 a.m. on a Tuesday morning to learn a little bit about Jump. As Chuck said, my name is Ross. I'm an academic ambassador. Basically, I'm just a Jump technical expert. My background, just so you kind of know where I'm coming from, actually isn't in statistics. Like many JUMP users, I came to JUMP by virtue of doing some research. I'm actually a cognitive scientist by training, so started learning statistics in a cognitive neuroscience lab and fell in love and started to use JUMP. And now I'm here just sharing JUMP with people either teaching statistics or analytics in some capacity or using statistics or analytics in their research. So you can see on the screen, I have this JUMP journal. That's what this window is called. This is a place where I just keep notes and links to JUMP files and things like that. You can see right at the top my name and contact information, as well as the name and contact information for your account rep, Chuck. So that's also, as Chuck mentioned, in that email that you got announcing this session as well. So please do reach out to Chuck for any questions about your license, what you can and can't do with JUMP as far as installing it and using it, and for any technical questions that you have about, what JUMP can do, how you do a certain analysis. I'm your person. You have my personal contact information, and you can reach out to me directly. No question is too small. Just feel free to shoot me an email if you ever need any help. So let's get started today. The title, as it suggests, JUMP for University Teachers and Researchers. This really is intended to be a pretty broad overview of JUMP, what it is, how it works, and its capabilities. It's really meant to be a first step in learning about JUMP for people who might not be as familiar. Though if you know a fair bit about JUMP, and I can see we have some intermediate JUMP users here, you're definitely going to learn something too. So please do stick around. Really, today's goal in one sentence is to just raise awareness of what JUMP is and how it might be useful, whether you're thinking about using it for teaching or for research. So I believe you had a hands-on training with SAS yesterday that some or maybe all of you attended. Today, we're not doing hands-on training. That can come as a follow-up step after we provide this overview to help you decide whether JUMP is actually going to be useful today. So after today, I highly recommend, if you haven't already, leverage the fact that you already have access to JMP Pro at no cost to you. It's already been purchased for the whole university, the whole campus at Western Kentucky. So go ahead and give it a try. And as Chuck mentioned, all faculty at Western Kentucky can arrange totally free, either a one-on-one call with me to help you do something in JUMP, or a group workshop on a specific topic to either just learn more about what JUMP can do, or to even have me, a technical expert in JUMP, help you do it. So just know that today is all about awareness, and going forward, we have all of the free personal support you might need to actually use JUMP effectively. So I appreciate everybody filling out the poll. I'm going to go ahead and close it now. That was just to help me understand, how many people here have actually encountered JUMP before and what you might be using it for. It looks like the majority of people here are considering using it for teaching and research. That's good. And as far as topics are concerned, pretty wide swath. It looks like half are interested in design of experiments, and then all the other topics up there, more than half, and in some cases all of us, but go figure, data preparation and data visualization certainly apply to all. So I'm going to end that poll now. I appreciate you providing that information. I'm also, just for the sake of the occasional bandwidth glitch that happens, I'm going to turn off my video for now, though I'll probably pop back up a couple times, but I do just like to show my face and say hi to everybody. As we get going, please do feel free to just drop questions either in the chat or the Q&A at any time. I have the chat and Q&A open on a second screen, so I can see them come in and answer them as we go. I'll also stop a couple times throughout just to see what questions may have come in. So looking at those poll results, we have a decent number of people who actually have never encountered JUMP before. This might be the very first time you're seeing it. We're also recording this for the benefit of people who weren't able to make it today, and I'm going to assume that at least a few of those people probably have never encountered JUMP before. So I want to begin simply by talking about what JUMP even is at a high level, so you can understand what you can do with it, how it might be different from other statistical packages that you might be familiar with or might already be using. So just to point out, right now I'm on a Mac and I am using version 16.2 of JMP Pro. So JMP Pro is the more advanced version of JMP that does everything standard JMP does, but has some advanced analytical capabilities not present in standard JMP. And this is what you all have access to at Western Kentucky. Now, if you're a Windows user, don't worry, you're looking at a Mac version. Other than a couple different things about where something is in a menu, for example, all of the actual analytical capabilities are the same in Windows. So everything you see today, you can do on your Windows machine as well. So what is JUMP anyways? Well, in one sentence, it's point and click desktop data analysis software, as I mentioned, on Windows and Mac. So you do install it just on your local machine, on your laptop or your desktop. I'm running it on my laptop right now. And you can do everything from your data import and prep through analysis and saving and sharing results, all through a point and click interface. So it is a no code environment, though there is an underlying scripting language that you can leverage if you desire. And what I think makes JUMP somewhat special, at least, I was a longtime R user before starting to use JUMP, and what I found striking about it at first, and what really drew me to it, was that it was really visual and interactive compared to what I was used to. So it had this very intuitive and engaging interface for everything from your really basic statistics all the way through very advanced analyses. And what I want to do to try to set the stage there for those of us who have never seen JUMP before is actually just show you what I mean instead of try to tell you. So I'm going to pull up some data right now, and we're just going to do a quick analysis together. I'm not going to explain, where I'm clicking and why. And the actual analysis I'm about to do, it's not really even that important. It's just one of many possible analyses. The whole point is to just boost our intuition for what JUMP is and how it works. So in the news recently, I'm sure we've all seen a lot of commentary on inflation and how cost of living is going up in many respects. And so I was actually not too long ago just looking at some cost of living data across the US, wondering which states actually had higher costs in different domains. And so I came upon this webpage that has a number of data sets that you can access. And so if you scroll down near the bottom, you actually find a table here just embedded in the web page of all 50 US states and various cost of living indices. So we have the total CPI or consumer price index, and then we have it broken out by different categories like groceries, housing, and so forth. And when I saw this, I wondered, okay, well, I mean, I can look at all the individual states and get an idea for how expensive they are in these various categories. I was actually personally just curious about geographic distribution of these things and how maybe different areas of the country might have similar cost of living profiles, if you want to say, so similar patterning of all these different cost measures. And so what I did in JMP was I built a quick interactive map. So here I have a map that's color coded by the results of some clustering I did on these cost of living measures. The clustering analysis, at least part of it anyways, is displayed on the left. So right now I have a 2-cluster solution. So I've said just break the country into 2 regions with similar cost of living profiles. And as you might imagine, we see that the Northeast and Mid-Atlantic region and then the West Coast are typically a little more expensive than the others. And that group also includes Alaska and Hawaii. So what I found particularly interesting, I figured if we were to say start to break the country down further, so actually increase the number of clusters in our analysis, that we'd see patterning kind of breaking down the individual coasts a little bit more. But even as I got to say the 4-cluster solution, I saw something that I thought was a little counterintuitive. If we look at that coloring now, it looks like California and then Connecticut and Rhode Island break apart from the other coastal states, as opposed to, say, California and Oregon breaking apart and staying together geographically. So that was interesting. And then I wondered, well, what could be the cause of that? And so I'll show you what I found. If we look at this, what we call a parallel plot, we have a different line for each of these clusters, and it goes across the different categories. So groceries, housing, utilities, transportation, miscellaneous, and their height on this y-axis just represents their relative mean. So higher up means more expensive. And you can see actually that the blue states are typically more affordable than the other two. But when we look at the purple and red states, you see what's clearly driving the difference right here, which is actually utilities costs, which I didn't realize. I used to live in California, in San Diego. My utility costs were relatively low because I didn't have to use air conditioning. But it looks like if I were, I may have discovered that is actually relatively expensive and patterns more with Connecticut and Rhode Island than it does with the fellow West Coast states. So this is the analysis I did. I grabbed our data off of the web and I created this interactive report that's a combination of data visualization and some, what some might say advanced statistics, in this case, hierarchical clustering. So what I want to do right now is actually show you JMP. I want to show you how you would do something like this in JMP to give you an idea of how it works. So let's actually close this down. What I'm going to do is grab the data first, straight from the web. So let's go ahead and just copy that URL. JMP has a lot of different ways of bringing your data in. One of those ways that we're going to use here is actually straight from a web page. So let's say open from a web page and give it the URL, and then grab that cost of living data table. So now this is in JMP. This is a JMP data table. Like any data table that you might have seen in another statistical package, each row corresponds to an observation. So here's Mississippi, here's Arkansas, so forth. And each column corresponds to a particular measure or variable. So here we have our different cost indices. So I'm going to clean these data up a little bit before we go any further. JMP actually has a full suite of data preparation tools that really make it a heck of a lot easier to get your data ready for analysis than it might be otherwise. First off, I just want to sort my table in alphabetical order. And I personally prefer, instead of working with full state names, to work with state codes, just the 2-letter codes. And so I need to get this column to, instead of saying Alabama, Alaska, to say AL, AK, Arizona, AZ, and so forth. I actually, because I do this a fair bit with geographic data when looking at data across the US, I maintain this table on my computer that actually has the mapping. So Alabama should read AL, Alaska read AK, and so forth. And just to give you an idea of how easy it is to clean up your data in JMP, let's just really quickly map our current data table to that key that I have there. So I'm going to use the recode tool to do that, which is just a general purpose data cleanup tool. In particular, I'm going to map to an external table, that state codes table, where I'm going to map the state names to the 2-letter codes. And let's save this as a new column in my data table, and we'll call it state code. And now we have it here. All right, so my data is cleaned up and ready to go. First thing, let's actually just take a look at it. Let's do some graphing. We're going to take a close look at this tool called Graph Builder in a little bit, but for now, we're just going to use it to create some simple graphs. Just to give you an idea of how it works, it's drag and drop graphing. So I could grab all of our cost indices, for example, and just put them on the y-axis and maybe request some histograms or something like that and make a quick graph. So if I were to do that, you can see, well, it looks like they're all pretty right skewed, these distributions. So that is, there are always a couple states that are a lot more expensive than the other ones. And you can see housing is exhibiting a much wider spread. So there's much higher variability in housing costs than in these other categories. We wanted to create a map, actually. So what I'm going to do is bring our control panel back up, grab my state code and just drag it to this map shape box here. JMP has some built-in geographic mapping capabilities, so I didn't have to do anything special. I just drag a list of US states and it knows that I should create this map. Now I might, let's say, color the map by the cost of living, just total CPI here. And so we can already see, similar to what we saw before, we have this geographic breakdown where it looks like in these darker colors, we're getting slightly more expensive on the coasts here. Okay, so let's actually build that map that I had where we were clustering these states by their cost profiles. So I'm going to go ahead and just get rid of that and put our map over to the side while I do this next analysis. JMP is what a lot of people, including myself, call a bit of a Swiss Army knife when it comes to analytics. That is, it has a lot of analytical capabilities that you're going to find, many of which live under this Analyze menu. And so basic to advanced things, from analyzing individual distributions to fitting regression models, doing predictive modeling and so forth. What I want to do is actually cluster our states. So I'll choose the hierarchical clustering tool, grab all of the individual cost categories, and JMP produces an interactive report for me. So it has actually centered on right now, if we click on it, a 6 cluster solution, but I could start simple and say, give me a 5 cluster solution and maybe ask for the quick summary there. And if I do, you can see it automatically colored that map for me. And now I have 2 clusters where it looks like the blue cluster is just more affordable all the way around than that purple cluster. But if I start to actually increase the number of clusters, we can see that the graph updates, the map updates, and we can see how these red and purple states start to pull apart according to their utilities costs. So there you go. I mean, it really wasn't a whole lot of clicks to get to where we started here. I have my interactive map and my clustering results, done my data visualization, my analysis. Now let's say I actually wanted to package this in some way, to actually share this outside of JMP. There are a lot of different options for what I might do. In this case, what I'm going to do is create just a quick interactive dashboard. I'm going to imagine that actually what I want to do is just provide this to my students in a course to be able to play around with a little bit. So I'm just going to combine these 2 windows, the graph and the clustering, into a quick dashboard. So here is that dashboard right here. And now I'm going to save it. So I'm going to export this. And because maybe this is early on in the course, some of my students haven't even installed JMP yet, I'm going to just export it as an interactive HTML page. So let's save that to my desktop. So now I actually have a file that I can share with my students that they can open in their web browsers. They can explore the results of the 4-cluster solution here. Maybe we'll actually clean that up for now, and maintain some of the activity of JMP, for example, the state selections and so forth. So this is JMP in a nutshell. It's pretty efficient and relatively intuitive to get around your data, to visualize and analyze it, and to import it and export your results. So I want to explain a little bit more detail about exactly what JMP is and what it can do before we get into some of the nitty-gritty about how it all works. So let's close some of this stuff down here. So as I hope to have demonstrated, JMP is what we'd call an end-to-end tool. So it does all of the steps or stages of an analytical process, from getting your data in to sharing it. When you open JMP for the first time, you're going to see this window. It's called the JMP Starter window, and it summarizes all of JMP's capabilities for you. So I recommend when you use JMP at first to familiarize yourself with what's here so that you don't miss any tools that might be relevant to you. So as far as data importing, for example, you could click on import and be able to see the various file types that JMP can import. In fact, this is a subset of all the file types. Some more specialized file types, including files from other statistical packages, are possible as well. Just to point out, we also, if you work with data in relational databases, so say SQL databases, you can query databases directly too. And as we saw, pull data from the web. As far as data preparation, we saw that Recode tool. That's just one of many data preparation tools. So for example, we often have to subset our data or combine data across multiple tables. Maybe we need to reshape our data tables, tall versus wide format. All of these other things, all can be done through JMP's point and click interface. There's a huge number of statistical analyses you can do here. So from your basic analyses like univariate analyses of just a single distribution, or maybe your basic 2-sample t-test, bivariate analyses. We'll actually take a brief look at Text Explorer, our text mining platform, towards the end. We fit a really wide range of linear regression models, from your just standard least squares all the way through to pretty advanced techniques. You can actually see here these little blue icons that say JMP Pro. That indicates features that are exclusive to the Pro version of JMP, which again, at Western Kentucky U-Haul have access to. Have a suite of predictive modeling capabilities, so neural networks, decision trees, k-nearest neighbor, support vector machines, also tools for automatic model cross-validation, model comparison. For some of us, things like time series analysis, nonlinear modeling are particularly important, so we have some of these specialized capabilities as well. Multivariate techniques like principal components analysis or factor analysis. We saw some clustering already. If you are in industrial statistics, then you would probably be very interested in statistical process control capabilities, or maybe measurement system statistics or capability analyses. And JMP is also, I should say, a world-class design of experiments tool. So if you teach DOE, there's really, I would argue, no better tool to do so than JMP, with its combination of powerful design capabilities and great analysis tools. And then finally, we saw the ability to share results. So as before, when we went to the export menu, I'll have to pull our map back up to access that. A variety of ways in which you can actually export things outside of JMP, whether that be in text or image format, directly into web pages, or you can even export directly into PowerPoint files, or here we have RTF, rich text file, which is also something that Microsoft Word works with. So you can get your graphs and analyses just directly into a document or slides. So that's like a pretty sweeping overview of all the things JMP does. And I bring bring that up just so that you probably do something pretty specific with JMP, and I hope that you may have seen that thing in that list that we just went through. But if not, please do browse it on your own because I did not mention everything. And I will just briefly, because we're looking at this map, I see a question has come through the chat. And that question is, does the mapping feature allow for mapping by counties in a particular state? So yes, you can do mapping by county in any US state using the FIPS code, which will probably be provided in whatever data set you have. But we do have mapping by county built in automatically. Okay, so JMP, we find, we go to universities and talk about JMP, and many people have heard of it, some haven't. I know we have a number of people here who are brand new to it. I do want to highlight that JMP is used pretty widely in both academia and industry. So if you go to our website, you'll actually find a list of, here's just the list of the US universities that currently license JMP. And I should say that this is an incomplete list. These are the universities that actually allow us to list their name here. And we don't necessarily do this for ad purposes. This is actually because it's important for people who don't know if their university has JMP or not to be able to go to a web page and look for their university. And if you see your university's name here, then you know you have a JMP license. And so once we get all the way down to the bottom here, you'll notice, where are we? Western Kentucky, right here. And so a lot of universities for teaching and research use JMP. A lot of companies do as well. So one of the things that I rightly hear frequently from faculty is, sure, this tool looks like it'd be good for teaching statistics, but is this a valuable skill? I want to prepare my students with software that they might actually use when they graduate. And so I want to point out the fact that thousands of companies license and use JMP. Here I'm on JMP's customer stories page. So this is where some companies who have had particular success with JMP lend their name and story for our purposes. So this is not even remotely close to an exhaustive list. But as I slowly scroll through here, if you can catch them, you might notice some particularly big names in a variety of different industries here. So you could check out our customer stories page if you want to get an idea about what types of companies use JMP to decide for you and your students if JMP might actually be something that would be worthwhile preparing your students to use in the real world. Now, finally, if you want to learn more about all of these things, about just kind of what JMP is at a high level, what value it brings, go to jmp.com/academic, and you'll find the webpage for our academic program, which you can browse just by role. So if you're faculty, if you're on research staff, or if you're a student. So if I were faculty, I might click Learn How We Help Faculty, and then decide, well, do I want to learn more about JMP, access some of our course materials, which we'll review towards the end today, or figure out how to get JMP, I can just click any of these. So if I go to Why Use JMP, we have a series of short videos that talk about JMP's capabilities, our teaching resources, assessment with JMP, and so forth that you can check out on your own time. Now, I do want to point out, so as I mentioned, I was an R user actually before starting to use JMP. And actually, when I was doing my dissertation, there were a couple R packages that it was important for me to use because they're standard in my field. So I would like to highlight that JMP actually integrates with open source, so R and Python. It actually also integrates with MATLAB. So if you use some of these other tools, it's not an either or situation. So, well, either I use JMP or I use R. Many users use both. JMP is the analytic hub that you can do all of your data prep and graphing and basic analyses. And then when it comes time to call out to a specialized routine in one of those tools, you can. All right, so that is what JMP is at a really high level. I want to spend the rest of the time actually giving you an idea of how it works. That is from the idea of or perspective of the JMP workflow, so that when you actually have your hands on this tool, you feel competent in getting around it. And then we'll actually look at some specific tools that are particularly useful to, I would argue, every single JMP user. And it looks like Lily has dropped the link to downloading and installing JMP Pro into the chat. And so if you don't have it installed already and would like to, go ahead and follow that link and you could have it installed today. Okay, so let's actually talk about how JMP works. To do that, I'm going to switch data sets here. So now I'm looking at the lipid data set, which is a data set of 93 individuals. We have various measures regarding their cholesterol levels here. So I have their total cholesterol, triglycerides, HDL, LDL, in addition to some other things like their sex, age, and weight. This is a sample data set that comes bundled in JMP, and you can always access these under Help, Sample Data. And so what I want to do right now is actually use this data set to try to show you what makes JMP, what makes it kind of specific in the way that it works, what we try to achieve with the tool, and as I mentioned, give you some basic pointers in the JMP interface so that you feel comfortable getting around it. So as we saw before, this is the JMP data table, one row per observation, one column per variable. You'll actually notice on the side we have a few other things. I said we had 93 rows. I was looking down here. This is a summary in that bottom left corner of all the rows in your data table. And above that, we have a summary of all the columns as well. Now you'll notice actually when you first open a JMP data table, at least starting in version 15, that JMP, because it tries to be visual, we recognize the importance of actually seeing your data. That we have graphs embedded right in the data table. And so if you're using, in this case, the most latest version, JMP 16, and you don't see those, look for this little gray bar icon right here, which will toggle these header graphs on and off. So we have some basic graphs right in the data table to help you immediately see your data. So for example, I can see that I have more males than females in this particular sample. The age range is from 20 to 40, and it looks like pretty positively skewed. So I don't have a whole lot of people in the upper range. It looks like most people in their 20s or maybe early 30s. And these graphs themselves are interactive. So if I actually start selecting observations, you can see that those observations get selected in the data table, and we actually see them highlighted in all of the other graphs. And I think this is emblematic of what JMP tries to do. It tries to give you interactive graphics all over the place because it's really important for understanding and exploring your data. So part of JMP's philosophy is to give you a graph with every single analysis. I mean, obviously, if we're going to put graphs in the data table, we want to have graphs everywhere. Just to give you a few examples, let's say I wanted to just do some univariate analyses of, actually, we'll just start with weight here through LDL. So I could open up a quick report that summarizes all of these variables, and you'll notice each one comes automatically with a visual. I didn't have to ask for a histogram or build a histogram. It just comes with it, in addition to all the summary statistics that we see below. And these graphs are interactive, just like the ones in the data table, so that if I start selecting observations, they get selected everywhere. So maybe I would actually grab, say, these triglyceride outliers here and be able to find them back in my data. So this is an example in JMP of what we call dynamic linking. So all the data tables, the graphs, the analyses, they're all linked together. So if you click on data in one place, it's going to get selected everywhere. So this is actually pretty handy in a number of different ways, and we'll kind of see that as we go along. But just to get back to a graph with every analysis, let's do a couple more analyses and see what kind of graphs they give us. Let's say I wanted to take a look at the relationship between sex, so male versus female, and the reported alcohol use. So I could pull up an analysis tool, and this is one we'll take a closer look at in a little bit, and say that I want to see the relationship between those two variables. So JMP provides me with yet another graph. This case, it's a mosaic plot. And so we see male versus female on the x-axis. The male column is wider because we had more males in this particular sample. And then we see the breakdown of the different categories of alcohol use. So none, less than 2 drinks per week, or 2 to 6 drinks per week. And it's totally interactive. I can hover over it to get a summary of any one of these quadrants. So I can see I have 43.48% of the females report not drinking, whereas only 31.43% of the males do. And make a selection in that graph. And again, now all the females who do not drink are selected in my data table. Here are a couple of them here, and selected in this other report as well. Let's take a look at one more. Maybe I want to assess the correlation between some of our measures here. And so now I have some scatter plots here, so a scatter plot matrix as well as a correlation matrix. So we can see some pretty tight correlations here, in particular between cholesterol and LDL. And as you might imagine, this one, of course, is linked to everything else. And so let's say, again, maybe I wanted to keep track of these folks with the high triglyceride levels. So they're now selected in every single report that I have open and back in my data table, allowing me to do something like this. Maybe say that I want to color them red and have them displayed as asterisks. And so now everywhere that they're plotted, they will appear that way for me so that I can keep track of them as I move through my analysis. So this notion of interactive graphs and everything being linked together is foundational to how JMP works. So if you're the kind of person who is looking at your data in multiple places, finding interesting points, trying to chase down other features of them or what make them interesting, or maybe even just find some outliers and just easily grab them and exclude them from all the analyses. You can do that through all of these interactive graphics. So I highly recommend leveraging that because it makes getting around your data a fair bit easier. Okay, so I'm going to go ahead and close some of these down and then highlight a couple more very foundational parts of the JMP interface that you should know about. So first, let's see, I'm gonna go ahead and clear our row states, get those markers and everything out of the way. And we'll go back to this contingency analysis of sex and alcohol use. When using JMP, one of the sayings that we have is that we never want anyone to go backwards. So that is, if let's say you wanted to do the analysis we're looking at right now, but only on a subset of your data, you shouldn't have to, go back, subset your data, create a new table and do the analysis from scratch. Or if you wanted to do this same analysis, but instead of looking at alcohol use, look at a different measure, you shouldn't have to close this analysis down and then start from scratch. And so we have some tools that really help you avoid starting from scratch. These are the local data filter and the column switcher that you will find everywhere all over JMP. Let's take a look at the former, the local data filter. I'm looking at all of the males and females in my study here. Let's say I actually only want to do an analysis on a restricted age range, so maybe the 21 to 25-year-olds. How would I do that in JMP? Well, I would not go back to subset my data. I mean, we have the ability, if you want to create a subset of a table, you could go to table subset and do that. What I'm going to do is go to the red triangle and choose the local data filter. So you're going to find this all over JMP. All you do is select which variable you want to filter on, and then use this interactive visual to actually control the filter. And so I could drag down, and as I restrict the age range, you can see on the fly that analysis is updating. I mean, the statistics are changing, the graph is changing. I said I wanted to do 21 to 25 years, so I'm just gonna actually type that in manually. Okay, so now this analysis is being conducted on just the 21 to 25-year-olds. Looks like we see the same general pattern. There's a higher degree of drinking in the male versus female group. Though for those of you who know null hypothesis testing, we might want to see if this is statistically significant. And if we look down here, we see some relatively large p-values. So it doesn't look like we have statistical evidence that underlyingly the two groups are different. So the local data filter, that basically lets us drill down on the fly and update our analyses in real time for subsets of our data. I'm gonna go ahead and include all of our data again. And now let's say that instead of alcohol use, I wanted to look at a couple of these other categorical outcomes like smoking history or heart history here, where heart history is just the age at which a family member, so a parent or sibling, had some kind of cardiac event. Well, so as you might imagine, then I'm not going to close down my analysis. What I'm going to do is update it from right inside. So I'm going to go now to the column switcher, which you're going to find under this redo menu. And so instead of looking at just the alcohol use, I'm going to look at all three of these categorical measures. And now I have this list where I can select one and the analysis is updated. So now we have smoking history instead of alcohol use. And it looks like the grand majority of people in our study report never smoking. And though we do see perhaps a higher proportion of smokers in the female category, but again, it looks like in this case, it's not statistically significant. And if we look at heart history, again, it looks like maybe females had slightly higher rates of cardiac events in their family. And it looks like, well, maybe we have a borderline result here, but unless we have a pretty good explanation for it, we might want to consider that a false positive. But this column switcher here allows us to just update analyses with different variables on the fly, so that if you have multiple variables that you're interested in, you don't have to just manually create a bunch of separate analyses. All you do is just select the variable from a list to get the analysis that you want. Now, one other thing, I think it's related to how JMP is generally visual and interactive. Something that I think every JMP user should know about and use extensively is a tool that, like the local data filter and column switcher, it's all over JMP. And it's called the profiler, and it's for visualizing and interacting with the statistical models you build. So whether that's a regression model, or maybe it's a machine learning model. So what I have here, I'm not going to build the whole model right now. We'll actually do that shortly. I have a model of cholesterol level by age and weight, and I've included the following effects in that model. So I have the effective age, the effective weight, I have the interaction between the two, and then I have quadratic terms, which just allow for curvature in the model. What I have below is this profiler. So this is a point and click tool for actually visualizing the model itself. So I have two panels. I have one for age on the left, one for weight on the right, and then on the y-axis, I have the predicted cholesterol from the model. So I can see that at an age of about 25 years and a weight of 164.5 pounds, we would predict a cholesterol of just under 200 points with the confidence interval in blue there. Now, what's nice is I can actually see what the shape of the relationship between these factors and cholesterol level looks like. So we can see a fair bit of curvature in the weight effect, and we can also see that the effective age is positively sloped. So cholesterol levels seem to go up at least a little bit with age. But I can actually click around in here and change the values of these factors and see how the output of the model, that predicted cholesterol, changes. So as I go up to, say, about 40 years old, we can see that at the same weight, we now have predicted cholesterol of about 225 points. We can also see the confidence limits. We know we have a lot less certainty about that prediction than we did down in the part of the model where we actually had more data. If you remember, we didn't have a whole lot of older people in our data set. Now, one thing I really like about this, not just to help us maybe in our own research understand our models, but it's actually really useful for teaching. I mean, I speak as a former statistics teacher myself. It's really hard, especially to explain something like an interaction to a student. So age by weight, they interact. What does that mean? Well, we can tell them all day that, well, it means that the effect of age depends on your weight, but it's easier to just show them. So I can change weight, and if you look at the age, you can see how at lower weights, the effective age kind of flattens out, and at higher weights, it becomes more pronounced. That change right there, that is the interaction, and you can actually just see it and play with it in real time using this profiler. So the prediction profiler is a tool that is all over JMP. It's actually really full-featured. You can do optimization and simulation off of it, as well as a number of other things. It's a great tool for being able to interactively work with the models that you build. So this is, I would say, the core idea behind what JMP tries to be in being a point and click analysis tool, this visual nature and the interactivity, making it easy and efficient and intuitive to get around your data. Let's actually talk about what I would say is a basic JMP workflow. So that is how an analysis in JMP works. Once I'm looking at some data, how do I actually do the analysis, starting from scratch here? So let's do an analysis. In this case, I'm going to take a look at cholesterol levels by alcohol use to see if people who report drinking more or less have different cholesterol levels on average. So the first step in doing an analysis is to choose a self-contained platform. So platform is just a word for these analytical tools that you're going to see all over JMP, whether it be a graphing tool, an analysis tool, a tool for designing an experiment. And I say that they're self-contained in that really each one constitutes a whole set of analyses all around the same basic kind of high-level analysis question or scenario. So here, our scenario is that we're going to have one X variable, one factor, alcohol use, and one Y variable, that is cholesterol level. And so if we wanted to do that, I would go to the fit Y by X tool, which is a general purpose tool for having an X variable and a Y variable and wanting to analyze their relationship. So let's take alcohol use and say that that's my X variable. Let's take cholesterol and say that that's my Y variable. Now you'll notice next to those two variables, they have these little icons. So we have the red bars, the blue triangle. That is represents the modeling type, as we call it in JMP. So is this a nominal variable, an ordinal variable, a continuous variable? Those are set back in the data table. So you can see them in this list here, and you can always click to change what modeling type it is. And based on the modeling type, JMP actually knows what to do with the different types of data. So for example, here I could actually use in the fit Y by X tool, this little key to know that, okay, well, if my X variable is categorical and my Y variable is continuous, well, then that gets me into this quadrant, which is a one-way analysis. Earlier, we actually had a categorical X and a categorical Y, and so that would yield a contingency analysis. And so here and other places in JMP just knows what to do with the data based on the modeling type. So you don't have to enter a variable and say, and by the way, treat this as categorical. You code that in the data table, and then the rest of the time you're using JMP, it just knows what to do. All right, so here's my output. And you might be saying, that's not a statistical analysis, Ross, that's just a graph. And that's exactly right. What JMP does is it doesn't produce analyses in their final state by default, because there are a lot of different things you might want to do when we're looking at a categorical X and a continuous Y and their relationship. And you shouldn't have to specify upfront every single statistic and analysis and follow-up analysis that you want. Instead, you get a dynamic output, an output that you continue to interact with to further refine your analysis. And you do that by using these red triangle menus that you've been seeing me use. So you can see a little red triangle right up here. And so these red triangles all over JMP are context-sensitive menus that give you additional options. So if I click on this, here are all of the different things I can do when I have a categorical X and a continuous Y. So maybe I want to first just ask for the mean and standard deviation of each group. And now I have it. And it's been added in this little collapsible section in my report window. And maybe if I decide that I don't want that displayed to me, I can even just take it away. So maybe here I would say, well, especially if I'm teaching ANOVA, I might say, well, don't forget, your variances across the groups, we're assuming them to be the same, so do an unequal variances test. Okay, there's my unequal variances test. Looks like none of the 4 different tests that JMP runs was statistically significant, so I think I'm good to do my ANOVA. Okay, I'm going to do my ANOVA now. All right, there's my ANOVA. I have some embellishment on my graph here. These are just representations of the confidence intervals in the 3 groups, and you can see that they largely overlap. So we don't have a statistically significant result in our ANOVA, and that's okay. But if we did, maybe the next thing I would want to do is compare all of the individual means. And so I could say do the t-tests on that. Maybe what I would want to do if I didn't have a statistically significant result is start to inquire about the power of this analysis and know how big my sample size would have needed to be in order for the difference that I saw to be statistically significant. Maybe I actually didn't want to use alpha of 0.05 on my test. Maybe I wanted it to be something different. All of these things are available under these red triangles. So you don't have to ever specify upfront all the things that you want out of your analysis. You just feed the variables that you want, and then you use these red triangles to fill it out however you like. And then once you finally hit an end state, you probably want to save this in some capacity. And so the typical workflow involves saving and then as necessary, relaunching the analysis directly from your data table. Under the red triangles in analyses in JMP, all the way at the bottom in the save script section, you're going to see a section that says save to data table. And what this does, let's just save it to the data table, and I'm going to call it ANOVA. And as you can see in the data table behind this window, there in this section right here, we have a number of different little green buttons, none of which say ANOVA right next to them. When I click OK, you can see that one that says ANOVA has been added. And what this is, if I just go to edit, is this is a little slice of JMP scripting language code, so we call it JSL, that actually reruns the analysis on the data that are in this data table. So at any time, I can just click this little green triangle and it brings the analysis back up in the state that I left it in. But again, it's been rerun in real time on the data. So if I make a change to the data table, maybe I have an ongoing study, and as I collect more data, I have a few graphs and analyses that I want to just be able to redo without having to, do anything more than the click of a button. All I would do is save all these analyses to the data table and then go through and just click all of my little green buttons to get all of my analyses back. And so this is a particularly powerful part of the JMP workflow. It allows you to reproduce your analyses whenever you want. It allows you to remember all of the things that you did in a compact form. It allows you to bundle it all with the data table, which is very useful for research collaborations. It's also very useful in teaching when you have sample data sets that you want to distribute to your students and you have some maybe analysis reports that you want them to work with or base their further work on. You can just bundle them right in the data table like this. Now, finally, when learning new software, whether it's JMP or anything else, help is probably the most important part. I mean, for those of you who maybe don't use JMP and are thinking about it, I completely understand switching costs. It's very, very real, and learning how to use a new tool can take time. And we try to ease the transition as much as possible by providing what we hope is really unrivaled help in a number of different ways, both in the tool and as just part of being a JMP user and having access to the JMP team. So I want to point out just a couple things that I think are really, really useful if you need to start learning JMP. So the first is how best to get help from JMP, like right from inside the tool, right when you need it. So let's say I am working with a simple report. Okay, here we go. So I'm just looking at the distribution of cholesterol loss over time. So this study was run over 3 years. And so this is change in cholesterol levels over a 3-year period for these individuals, at least 42 of them for whom completed the study. I'm looking at this and I see this graph. And maybe I remember that it's called a box plot. Maybe I don't. Even if I do, I might say, well, wait, what's the red region? What's the difference between the line and the diamond? I don't remember how the whiskers are calculated. This is a common scenario when looking at output from statistical software. Some of it you know, and some of it you don't. So what do you do here? Well, instead of maybe Googling box plot, if we can remember that that's what it's called, or going to the full JMP documentation under help and just trying to find it, I recommend using the question mark tool, or otherwise known as the help tool, which is just in your toolbar at the top. You can see now I have this little question mark instead of a pointer, and as I move it, it highlights different parts of this window. So let's go ahead and just highlight the box plot. And so that has taken me directly to the help page for the box plot itself. So I can see, okay, there are the whiskers. Oh, right, the quartiles. Well, it looks like that red bit, that's called the shortest half. I have the full explanation. Oh, right, okay, here's how the whiskers are calculated. And so this question mark tool got me straight to the help I needed right when I needed it, right from inside JMP, to just save me a lot of time trying to find what I need. So I'd recommend making very liberal use of this question mark tool as you kind of get up and running with JMP. Now, I do want to point out the help menu itself is a lot more than just the technical documentation, which you can get to right here. So where we just were, that's one page in the larger JMP help, but there are some other things you can use. So for example, interactive tutorials. Maybe I open up Jump for the first time and I say, I don't even know where to click or how to get started. Well, you could go to the beginner's tutorial, which, popped up on a different screen for me. That's all right, let me just bring it down here. If I can grab it, there we go. So welcome to Jump. You should take this 5-minute tutorial on the user interface. Exercise 1, opening outlines. Okay, I think I get that. What else should I know? Red triangle menus, they're very important. Try using this one. Oh, okay, I made a selection and something happened. That's very good. Okay, let's open up a demo table and launch a sample analysis and so forth. So you can just take some of these tutorials, which you can see are for the basics and some basic analyses and creating graphs, instead of trying to just figure it out on the fly as you go. Now, we won't take the time to look at it, but if you want to get help from real people, so Jump staff and Jump users, one of the best ways to do that is to go to community.jump.com, where like the communities for other software you may have seen, we just have a vibrant community of users who post questions and answer questions and help each other out. And it's a great way to get to know Jump as well. And then finally, the academic team, we have a series of webinars. So if you go to jump.com/academic webinars, you can see the webinars that are coming up. And these are on topics related to both teaching and research, from basic to advanced topics. We've actually already had 4 webinars this semester. We only have 1 more coming up before the end of the spring semester series. And it's on analyzing functional data. So you could always click here to read more and sign up, or if you'd rather see some past webinars, click this link to go to the academic webinar library, where we have a full library of pre-recorded webinars on a variety of topics. And these will all be about an hour long, deep dive into specific topics so that you can actually learn the parts of Jump you need to use in greater detail. So again, there are a lot of different ways to get help in Jump. I've just talked about 4 of them. There are plenty more than that, actually. But again, we recognize that it's always a commitment learning a new software tool, and just know that you're not left to just read some technical documentation and click around on your own. There are a number of ways you can get the help that you need, including from real humans. All right, so with the remaining time that we have, I want to just talk about some specific Jump tools that we can all use, and then highlight some more advanced analyses to start to give those who are really interested in maybe specialized methods for research an idea of what you have access to by virtue of having Jump Pro. So these tools that I'm about to show you, we've actually already looked at all 4 of them, these 4 really foundational tools, but I want to give you just enough information on how they work so that, I mean, right after this, if you wanted, you could actually fire them up and start using them productively. And so we're going to look at this data set. So this is actually from an experiment on cleansing coal particles from an industrial tank. And we have created and are testing 3 different polymers for cleansing the coal particles. So here are the different polymers that we've tested. And here are the coal particle measures, where higher is better. And then we also had this covariate, so pH in the tank, that wasn't controlled, but we monitor it and actually record it on each run anyways. This is actually, as you can see, when we have the exact same number of observations for each polymer, because this is a simple experiment. And now DOE is a pretty in-depth, robust topic. I do just want to highlight how easy it is to create an experimental design in Jump. So if you go to the DOE menu, this is where you're going to find all of the design of experiments tools, including what we would call our modern approach to DOE. So statistically optimal designs, algorithmically generated designs. This is something where Jump is a world leader. Or if you're teaching out of your classical textbooks, all of the designs that you would be teaching in your course, like your screening designs, your response surface designs, or the one I learned first, the full factorial. So if I wanted to make a full factorial design for this study, I would simply specify what my response is. And then I would say, well, maybe we're going to control pH. So I'll say I'll do a 2-level continuous factor that is pH, and we'll range it from 6 to 9. And a 3-level categorical factor for our polymer. And we called it A, B, and C. Okay, I'll randomize my run order. I think that's a good idea. Let's see, I also want to do some replicates here for statistical power. So I'll do 3 replicates and make my design table. And so now I have my experimental design right here, ready to go, place to record my data, and a couple helpful things like design evaluation tools. So if I wanted to do a power analysis to figure out what my power is for detecting various effects, I could do that. Or maybe I wanted to look at the variance of the predictions across the design space, and so I can actually analyze that as well. It also comes bundled with the appropriate statistical model for the analysis. So in this case, this is an ANCOVA model. So I just have one categorical factor, one continuous factor in their interaction, and this will actually launch that analysis for me so that I always do the right statistical analysis for the design that I've created. So I don't mean to get deep into the details of design of experiments. I just want to point out that we do have the full suite of DOE tools, and if you teach DOE or use DOE extensively, JMP could really be a great tool for you if you're not using it for that already. But anyways, let's take a look at these 4 tools that are pretty foundational to JMP. And we'll start with Graph Builder. So first I get my data in. I just want to create some graphs to get an idea of what effects might be there. You can find Graph Builder at the top of the graph menu. As we briefly saw, it's a drag and drop graphing tool. So I take my variables on the left and drag them into drop zones on the right. So let's just take a look at the number of coal particles extracted from these using these different polymers. What I'm going to do is take coal particles, and as you can see, as I'm moving it, you see these blue areas, these drop zones appear. It's all the places I can put this variable. So I can put it on the x-axis. It just spreads out the coal particle measures on the x, or do it on the y. Then I'll take the polymer and let's say put it on the X. And so now I have those coal particle measures split across my 3 groups. Up here is my ribbon of different graph elements. So maybe instead of this dot plot, I want the histogram for each group, or maybe I want a box plot. Maybe I want a box plot and the dots. I think maybe not. Let's undo that. Or maybe I want a bar graph. So I'll click the bars. Okay, so here I have a bar graph where each bar represents the mean. And I know that because in my options for the bars over here, it says summary statistic mean, which I can change to any number of statistics that I want. I can use these controls on the left to do additional things with the elements in my graph. So I might, let's say, add confidence intervals and maybe a label. So now I actually have the means displayed. Okay, so it looks like we have maximum extraction with polymer A versus B and C, though those confidence intervals are relatively wide. Now, one thing is I measured pH. This was just an uncontrolled covariate. I want to make sure that this seeming pattern here, where we have higher extraction for A than B and C, holds across different pH values. So I'm going to add that to my graph, and maybe you can see there are a lot of different places I can put that. So pH here, that seems to be a pH bar graph. I don't know about that. Maybe overlay. Okay, that looks a little weird. You can see I can just start dragging this around to try to figure out where it makes sense to give me the graph that tells the story that I want. So, okay, well, here we go. I have this 3-part bar chart split out by different pH levels. I'm going to right click actually. You can right click on all kinds of things in these graphs and actually change how many levels pH is split into. And let's just say 2, we'll go low and high. Okay, and well, these confidence intervals started to get wide because we're drilling down into our data. Looks like we might still see that same trend. So perhaps it holds regardless of pH. So this is Graph Builder. You drag and drop your variables in all these different drop zones, declare what elements you want in your graph, control those elements with these controls on the side, plus maybe the occasional right click to access some additional options. And with that, you can create all kinds of different graphs to help explore your data. All right, so now what I want to do is actually just summarize my data. I just want to know, what's the mean and standard deviation of each group. Here I had a designed experiment where I know I tried these 3 polymers the same number of times. In other cases, I don't know that. Maybe what are the relative proportions of the different categories? For univariate statistics like that, you want to use the distribution platform. So that actually lives at the top of the Analyze menu right here. And this is your one-stop tool for all univariate statistics. So I'm going to launch it, put all three of those in the Y columns role and click OK. You can see for each, I get a graph and summary statistics. And this obeys the modeling type. So for continuous variables, I have histograms and box plots along with mean, standard deviation, confidence intervals, and a couple other measures. And then for this categorical variable, I get a bar chart and the relative proportions, which we can see is 1/3 for each of the three polymers. And you see these red triangles everywhere. And that's how I can request additional graphs and analyses. For example, I might, if I'm doing an analysis, want to check for normality on this coal particle measure. And one of the ways that we might do that is actually, let's see here. There we go, the normal quantile plot. I always forget that it's so high up on the menu. So I check a normal quantile plot, and well, while that doesn't look normally distributed, at least according to this plot, all the points fall within the bounds here and along the line, so I think maybe I'm okay. Maybe I want to do a statistical test on the standard deviation of pH. We're trying to keep our pH within a certain standard deviation. We don't want it varying wildly all over the place. Typically, we want to make sure that it's no greater than 0.5. You can see down here it was actually 0.98 almost. So let's just do a quick test on that. So I'm going to go to test standard deviation, enter my null hypothesis value, 0.5, and now the standard deviation test has been added. And then it looks like, unfortunately for me, I do have a statistically significant result. So I think our standard deviation is higher than target right now. So this is the distribution platform. For me, every data set I ever bring into JMP goes straight into the distribution platform because I want to know what data I have graphically and numerically, and this is the place to do that. Next tool everyone can use is this fit Y by X tool that we've seen before, so I won't belabor the point other than just to provide a quick reminder. If you want to look at relationships between pairs of variables, you have one X and one Y, fit Y by X is the tool to use. So I might say put coal particles in as my Y and then look just individually at the effect of pH with the coal particles and polymer. When I click OK, I get two analyses in this case, and they're different. As we know with the JMP modeling types, JMP knows what to do with the data. So when I have two continuous variables on the left here, I might do something like fit a linear regression, and it looks like I do have a statistically significant positive relationship there. And as we'd done in the previous example, maybe I would do an ANOVA on the effect of the polymer. It looks like I have a statistically significant relationship there. So fit Y by X is where you go whenever you have just pairs of variables, no matter what type of variables those are. And then finally, we would really analyze these data, the full model, using the fit model tool, which is the general purpose linear regression tool. So I'm going to go to Analyze, Fit Model to fit the final analysis. So again, this would be an ANCOVA model. So we have a categorical X, a continuous X, and their interaction. So this looks a little different. This fit model tool actually is a general purpose regression tool. You can see it fits a lot of different types of regression models. We're about to do standard least squares, but you can see we are definitely extending well beyond those capabilities all in one regression tool. So I'll put coal particles in the Y. I'm going to take pH and polymer. I could add those to my model effects. I could select pH and polymer and cross them to create their interaction. Or if I delete those, let me select these two and then use a model macro. So this is just a shortcut to common model types, like the full factorial model, for example, which will yield the same thing that I had just built manually. You can see JMP has defaulted to doing a standard least squares model because I have just a regular old continuous variable here. I like that, so I'll click run. I get out an interactive graphic, as you generally do with JMP. A summary of the effects, including their p-values. So it looks like everything here is statistically significant. We are accounting for 97% of the variability in the coal particle extraction with this model. Here are the individual parameter estimates in that regression model. the greater details of these statistical tests, and then of course a whole lot of other options as well. So I might diagnose this model. Let's plot the residuals by predicted to just make sure that that looks random, so that we don't seem to have any maybe correlated errors or maybe non-normal distribution. And that looks pretty random, so I'm pretty happy with that. And as we saw before, I mean, really where to go when you build a model in JMP, you want to go to this profiler here. So here we have the visual representation of our model. So I can choose which polymer that we're working with and actually see the relationship between pH and coal particle extraction. And maybe in this experiment, I want to know, well, okay, well, which polymer should I use and what pH should I be set at to achieve maximum extraction? And that's something that I can do using this profiler. So I've now declared, and that's what this line represents here, that the more coal particles extracted, the better. So go ahead and find me the optimal settings here that I should use going forward. And so it looks like maximum pH and polymer A. But maybe actually, polymer A is much more difficult to create in the lab. And I'm wondering about the viability of polymer B. And so I could just select that and see, okay, well, looks like my extraction would still be just shy of 400 compared to A, where it was just over 400. And maybe that's acceptable to me. And so I can use this model to actually figure out maybe what I'm going to do for this process in my lab going forward. But this is the fit model tool. Again, you just specify the effects in your model and what type of model you want to run in the dialog. And then just like everywhere else in JMP, you get your interactive graphics, statistical summaries out, and all of your additional options under that red triangle. So those are 4 JMP tools I think everybody should be familiar with. I have yet to encounter a domain that doesn't have use for graphing, for univariate statistics, for simple bivariate analyses, even if it's just quick and dirty, getting to know your data, and for just basic regression modeling. These may not be core to what you would ultimately use JMP to do, depending on what field you come from, but I think we all do have use for tools like this. Now, let's spend the rest of the time we have taking a look at some more advanced analyses. And we're going to do that because you all have access to Pro, which is great because it enables you to do some very, very sophisticated things that may be useful in particular in your research, though perhaps in maybe some graduate level teaching as well. So we're going to take a look at some more advanced stuff. I'm actually not even going to click through doing some of these analyses. I just want to kind of build your intuition for some of the more advanced stuff you have available to you. And of course, as we do that, if some of this is not from your domain or techniques that you're not familiar with, you might see 1 or 2 of these and go, I don't really even know what that stuff is. And that's okay. We're just going to spend a couple minutes on each one. Hopefully you do see at least one where you say, oh, okay, yeah, that one might be useful to me. So as we just saw, with that fit model tool, we did a simple least squares regression model, but we have some very advanced regression methods like mixed models when you have maybe repeated measures data or you have time series data where you might have some autocorrelation. We have generalized linear models, so that is when you have non-normal distributions, and also some penalized regression models. So if you're familiar with things like lasso, elastic net, ridge, all of these methods are available in that fit model tool. For example, let's say that I need a mixed model because I've done a study in which I have tagged several animals and I'm looking at the radius of their roaming radius across different seasons. And so I've measured 3 coyotes and 3 foxes once per season, looking at the number of miles that they've done. When you measure the same individual multiple times, you need to account for that statistically because not all of your observations are independent. This gets us into mixed model land, and fitting a mixed model is quite easy in JMP. So just to provide one example of some more advanced linear modeling, if I go to fit model, under this personality, I can select mixed models. Say I want to model the miles that people or these animals are roaming. I want to assess the effective species, season, and their interaction. And in this case, I also want to account for the fact that I have repeated measures across subjects. And as you'll notice, the way I've coded it, I use the subject identifier number 1 for both fox and coyote. So here's fox number 1, coyote number 1. So it means we actually, in the way we've structured the data, have nesting going on. So subject is actually nested inside species, and I can specify that as well, and then run our model. And so now I have a specialized regression output for this particular mixed model where I can see how much variability is due to random variation across the subjects that I measured repeatedly. I can actually see the individual random coefficients. So these are the regression terms for each of the individual subjects in my study. And I have specialized tools for performing either marginal or conditional model inference. So for those of you who aren't familiar, this would be inference across all subjects, basically averaging across them or assuming that they're just random, versus actually analyzing each individual subject on their own. So I might pull up the conditional profiler and say, okay, for fox subject 2, here's the model estimate of their true roaming across the seasons. This is just a quick example of one more advanced regression model. And as you can see, use the same intuitive tools to fit it as you would a simpler model. Using JMP Pro, as we mentioned at the outset, you actually have access to a wide suite of machine learning capabilities for predictive modeling. Here's an example from the financial domain. It's a data set on home equity loans. So our outcome here is whether somebody defaulted or not. Here we code it as good risk if they paid off their loan or bad risk if they defaulted. And we have all this information on the loan itself and the borrower that we might use to build a predictive model of who's going to default. Because in this domain, cross-validation is very important, we've divided our data into training, validation, and test sets using, in this case, I won't show it, but a built-in tool for doing so under our predictive modeling menu called Make Validation Column. And now I can actually run some machine learning algorithms on this to create a predictive model. Maybe I will create a decision tree at first. So I will put my outcome variable as y, here are all my x factors, and then tell JMP, this is my training validation test split that you should use. And then JMP will automatically validate and choose the best model. So as I split my decision tree, we can see debt to income ratio is predictive, number of delinquent credit lines is predictive. And so I can ask JMP to then just auto-validate this model for me to get us to the final decision tree. It's a pretty simple one here. Or I might use a different method, and I'll just run this right now. So here we've done a bootstrap or random forest, which is essentially a wisdom of the crowds approach where you, based on bootstrapping, so random sampling from your data, create multiple decision trees and average them together. And so you can see all of, if you're in this area, all of the fit statistics that you might expect and graphs, including your ROC curve for classification. Because this is a model, we have a prediction profiler, though you can see that the nature of the relationships captured by a model like this look very different than those in a typical regression model. And now in a situation like this, we are basically predicting the probability of loan default based on a number of factors. And when we do that, we often talk about decision threshold. So what probability should we, at a certain point, deny somebody a loan? So we have tools for doing that. Here, we are currently dealing with a cutoff of 0.5. So if your probability of default is 0.5 or greater, we're going to deny you that loan. And if we look at our confusion matrix over here, it looks like we actually miss about a third of all the defaulters. We end up issuing them loans, but we can interactively change the decision threshold and see how that affects that false negative rate. And so as we get farther and farther down, maybe to about 0.2, we can get that false negative rate down to just about 0.1. So JMP has a variety of great interactive tools for either doing or teaching machine learning techniques, which I know is central in a number of domains, especially business and finance. If you deal with raw text data, and I know in our initial poll, a number of people indicated that they were interested in that. JMP has a text mining tool called Text Explorer, which lives under the Analyze menu right here. consider these data. These are real data from a survey that the city of Toronto did back in 2013 on whether people were in favor of building a new casino in the city. So here we have whether people said, yes, I'm in favor or no. And here's their stated reason. So this first person is not in favor because they don't want to promote irresponsible gambling, among other things. And so we can use Text Explorer to try to better understand what's driving people's opinions. So we might do that simply by building a word cloud. So here I have the most common terms colored by their association with support. So red terms are those that are associated with people being against the casino, and blue before, or in favor, excuse me. So of course, people who are talking about addiction, or we've turned on stemming as it's called here. That's what that dot means. So if I hover, you can see we've collapsed across, addicting, addicted, and so forth. We're talking about social problems or crime. Those folks tend to be against it, but people focusing on jobs and revenue and tourism tend to be for it. Now, we might want to get at some larger scale themes in these data. And so we have a variety of more advanced text mining techniques, all exclusive to Pro, that we might use. So let's take a look. Actually, I'm going to do a latent semantic analysis, which this is basically dimension reduction on text data that can be used to find semantically similar terms or documents, or in this case, responses to the survey. And so let's actually request a topic analysis. So lists of terms that might represent underlying themes. So here's one where people are mentioning things like cost, social, benefits, problems. So it seems like people focusing on social costs, especially if we get down to health and welfare, or maybe even some darker terms there. Whereas topic 3 is quite different. Here we have some people focusing on new jobs. They're mentioning the Woodbine racetrack, which actually had a successful casino opening before this survey. And we can even see addiction, family problem, and crime, all with negative numbers, indicating that the people who are talking about jobs are very unlikely to be talking about addiction or crime, for example. This is just one very quick analysis we do with Text Explorer on data like this. You can see there are a number, including a very popular one that had been long requested, sentiment analysis, which was just added here in Pro 16. And so I think I'll probably stop the review of advanced methods there just for the sake of time. If you want to learn about functional data analysis, so this is when you're working with curve data, so any continuous measure that extends across another, whether that be time or space or frequency. There's some advanced methods in Pro for analyzing those kinds of data. You can learn about that at the webinar on Thursday. And then plenty more that I was never planning on actually trying to get into today. For example, multivariate methods like principal components analysis, partial least squares, factor analysis, reliability time series. We've, in all of the things that we have already seen today, we have seen just a fraction of all the different analytical capabilities of JMP and JMP Pro. So if you're curious, does JMP do X, this thing that I need for my teaching or research? There's a good chance the answer is yes, and I'd be happy to talk with you a little bit more to determine if it does in fact have what you need. Now, before we wrap up, I just have one last thing that I would like to talk about, and that's teaching with JMP. We have a lot of university instructors teaching statistics in a wide range of fields with JMP. And if you would ever consider doing that yourself, I would like you to know that you have a lot of support from us, the JMP academic team, in doing that. There are a number of concept demonstration applets that we, the JMP academic team, have in collaboration with some others actually built into the tool. And you can always find those actually in our sample data library. So without getting into it, I'll just very briefly demonstrate one. If we go to our teaching scripts and interactive teaching modules, you'll find a number of teaching modules to demonstrate things like sampling distributions and hypothesis tests, or I'm going to do confidence intervals. So here I have a simulator that will randomly sample from a population that we specify. So this is the IQ population, which naturally has a mean of 100 and standard deviation of 15. We'll draw a sample, let's say of size 30, and calculate a 95% confidence interval. So I'll draw one sample that had a mean of 95, a standard deviation of just under 15, and here are the actual observations. And then Right here, this green line represents the confidence interval. And we can see that it contains the true mean of 100. But we know for teaching confidence intervals that what a confidence interval is the interval such that 95% of all possible intervals will contain the true mean and 5% won't. So we can demonstrate that here. Let's actually draw, let's say, 20 more confidence intervals and animate all of these samples and the intervals. And you can see one red one that didn't contain the true mean pops up. We would in fact expect about 1 out of 20 to not contain the true mean. And as we keep going, we can see that that's the case. And we can use an interactive demonstration like this to help boost students' intuition for what a confidence interval really is, and the fact that, well, it either does or doesn't contain the true mean. There's no probability to that. The question is, whenever I get a confidence interval, did I get one of these good green ones or did I get one of these bad red ones? And I don't know. I only know what confidence level I used to compute it in the first place. Now, I mentioned before, I want to reiterate, there's a wide range of free teaching resources, either to complement your course or maybe just lighten your load. And all of these are at jump.com/teach. So if I go there, you will be able to basically just choose which course you teach or the closest one. So we'll just go to intro stat for right now. And you can access from here all of the various teaching resources that we provide. The top level ones, finding books that actually incorporate JMP examples so that the book itself helps teach the software. We have a range of step-by-step guides that you can access here or at jump.com/learn, where for any of these, they are a brief instructional video paired with a one-page guide. Let's take a look at, assessing normality of a distribution. So maybe your students are doing this in your course. You don't want to deal with the questions of how do I do that in JMP? Let these videos do it for you. Here's a 2-minute long video walking through the process of assessing normality in JMP that you can provide to students maybe on your syllabus, and then have them take a quick PDF guide with them to remember how to do it when they're doing their assignment. So when you get those questions, well, how did I assess normality in JMP? You can point them to this instead of having to show it yourself. And finally, we actually have a full-blown stats course that you can use to help structure your own course in any way you like. You'll find that at jump.com/statistical thinking. This course is actually featured on Coursera as well, but here's where it lives on the JMP webpage. You can see we have different modules, for example, on basically exploratory graphing, hypothesis testing, design of experiments, and more. Each one of these is a series of instructional videos with exercises. You can just assign these directly to your students, or you can actually request the materials and then use them in your own course in any way you like. And so this is basically pre-built instruction that you can use to maybe lighten your load a little bit in course design or evaluation. So that is our sweeping, but perhaps not totally comprehensive overview of JMP and what it can offer to your teaching and research. I just want to highlight, again, the goal today was awareness. You probably are saying, if you've been with us this whole time, that was a lot. I mean, maybe that looks good. I think I might be able to use that, but that was a lot. Remember, the goal today was not to learn how to do any of that stuff. That's what our team is here to help you with. JMP pays me to talk to faculty all day about how to use JMP. So we can connect for a one-on-one and I can walk you through a specific analysis or just answer a couple questions. Maybe you and a couple colleagues teach, I don't know, multivariate methods, and you're like, I could stand to do an hour overview of some of these tools that we need. Can we do that? All you have to do is email either me or Chuck. Contact info is right here, and also in that email you got announcing the session, and we can arrange a call or workshop with you totally free of charge. This is included in your license. You pay nothing for this. I will show up on your screen and teach you how to do whatever you want. All you have to do is shoot me an email. So I see a couple things in the chat. Let's see. Somebody says, when should I use JMP SAS versus when should I use SAS VIA? That one really depends on the use case. So JMP, I will just speak to what JMP is particularly good for. JMP is particularly good for interactive data exploration and analysis. So if you're pulling data in, you have a lot of different things you want to do very fluidly, very quickly in a highly visual nature. I have a new data set in, I need to just get some quick summary stats. I'm going to do a couple graphs, do a hypothesis test, and get on with my day. As you saw, JMP is a great tool for that. From start to finish, you'll be done in 5 minutes. That is the type of situation that I think is really applicable for a lot of university researchers. I also happen to think, especially because of how much we support teachers, JMP is a fantastic tool for teaching. We'll see if there are any other questions hanging out in the chat. Oh, to the people who said thank you, you are very welcome. So I don't know if there are any final questions. I'm happy to just hang out for a little bit and answer them. Before we do that, maybe, I don't know, Chuck, if you have anything that you want to say before we close up, because I do see we are at 10:30 Central here.
Hey, Ross, I think you touched on everything. They've got our contact information again. Any question, whether it's about the license itself or about using JMP, Ross or I would be able to help. So thanks again, Ross. You did a great job.
Okay, thank you, everybody. And I guess, Lily, before we part, I will, as soon as Zoom is done processing the recording file and the link is ready, I will send it to you, and you can send it as far and wide as you like. Okay, so I guess that'll do it. Thanks, everybody, for making time to learn a little bit about JMP, and I hope you have a great rest of your day, and I do hope to hear from you.
Thanks, Ross. Thanks, Lily.
Bye, everybody.